what's going on, everyone? Trey with Modern Ed here. We're going to go over yet another rule of logarithms, and today we're going to be going over the quotient rule and exactly what that looks like, why it is what it is, with a little bit of a proof, as well as an easy, medium, and hard problem to make sure that you're well on your way to crushing your next math test. Let's get into it. Okay, so what the quotient rule of logarithms says is that if we have a log to a base b, and we have some number up top, and we have some number on bottom, a numerator and a denominator, what ends up happening is that this is actually equal to the logarithm of the numerator minus the logarithm of the denominator, and as long as we have the same base, we're going to be just fine. So why is this the way that it is? Like, you know, a lot of times we look in a textbook, we see it, and we can draw some sample problems, but why actually does this property work? And well, I'm going to go over that right now and show you. So let's just say that log base b of x is equal to m, some variable, it doesn't matter. And let's say that log base b to y is equal to n. Okay, so first things first, in one of our last videos, we worked on how to go from the logarithm form into the exponential form. And go ahead and take a look at that video if you don't really understand this part. But if you remember the little loop-de-loop that we did, it's the base to this power over here is going to equal to that number, this little loop-de-loop that I always like to draw. Even now, you know, 10 years into my math teaching career, I still do that just to make sure that I know what I'm putting where is correct. It's just a really simple thing to do. So know that with my little loop-de-loop, I don't know what to call it, but not loop-de-loop method, I guess. You could just say that that is equal to b to the power of m is equal to x. And let's say that we're going to do it for down here. We'll have b to the power of n is equal to y. Okay, so let me show you why I did that. This is the quotient property. So let's go ahead and start doing some quotients. Let's divide some numbers. So let's say that I am going to take x divided by y. And you know what else I would have is that would be b to the power of m, because that is x. Remember, x is b to the power of m, y is b to the power of n. So in the bottom here, I have y to the left. So over to the right, I'm going to have b to the power of n. And so if we also went over in a previous video these exponential simplification rules. And in this case, when we have the same base, b, and that's also in the denominator, what we can do is just subtract the exponents and write it as one base. So what this would end up looking like is x over y is equal to b to the power of m minus n. Okay, and again, if you don't remember that, we got the link to the video in the description or in the corner. It'll be somewhere, you'll find it. Okay, so now that we have this relationship set, let's go ahead and take the logarithm of both sides, because what we do to one side, we have to do to the other. So let's just say that we're taking the log of base b to the power of x over y is equal to log base b to the power of, of b minus n, not to the power of. So we have log base b, x over y over here, and over here we have log base b to the b to the m minus n. So what we can do now is split these up, okay? So what we can do is, I'll rewrite log base b to the power of x over y, and we're actually going to learn this property in another video in just a second, but what you'll end up with is that, and so when we're looking at the right side here, log base b with b to the m minus n, well, if you remember what we went over in our product property video, you'll know that what we can do is just move those downwards, okay? So if I had m log b, base b minus log, n minus n log b to the b, okay? That's a perfectly fine statement to make. But if you remember what we do with our little loop-de-loop thing, we're looking for a power that makes b equal to b. It makes our base equal to this number here. And so what power would make b itself b? Well, it's just 1. Anything to the power of 1 is just itself. So what this is going to end up simplifying as x over y is going to be equal to m minus n. Because again, log base b to the b is just 1. Because b to the power of 1 is b. So therefore, it's 1. Okay. Now all we have to do is make a little quick substitution, because in the beginning, we stated what m and n were. We stated that m was log b to the x, and we stated that n was log b to the y. So what this is going to end up being is, drum roll please, log base b x y to be equal to m log b to the x minus log b to the y, which is n. Remember, n was just log by. So what does this mean? This means that if we are ever given a logarithm with a base b with two numbers being divided by each other, all what we can do is split that up so that way you're taking the log with the same base of the numerator minus log of that same base with the denominator right here. Or in the opposite direction, if you wanted to combine them or condense, you could end up saying, okay, if I have log b with some number minus that same base, log of the same base with y, some other number, well, what I can actually do is just rewrite that as 1, and I would just have to divide those two, with this one being on top, this one being on bottom, my numerator and denominator. All right, so now that we kind of have that cleared up a little bit, let's go ahead and take a look at an easy problem. And you know what? The easy, medium, and hard problem in this series is they're all pretty easy because once you actually get into combining the properties and expanding and condensing them, that's when things can get a little bit tricky. But I just want to go over a couple problems to make sure that you understand the very basics of what we're going over. So we have log 749 minus log 77. Okay, well, how am I going to simplify this? Well, remember that what I can do is I can say log base 7, and since this has a base of 7 and this has a base of 7, I'm subtracting them. That means this will be my numerator and this will be my denominator. So I'm going to have 49 over 7, and I'll have log base 7 to 7. And I can actually keep going with that simplification because remember that whole little loop-de-loop thing. Let's just say that this equals x, some unknown number. Well, 7 to the power of what equals 7? Well, 7 to the power of what equals 7? Well, it's just 1. So this whole thing, log base 7 of 49 minus log base 7 of 7, excuse my terrible handwriting, is just equal to 1. Okay, fair enough. Let's take a look at a medium one. Okay, so now I have log base 4 of 64 minus log base 4 of 16. Let's rewrite this as log base 4, and I'm going to have 64 on top. That's my first one, minus, okay, 16 is my second one. That's my denominator. That's going to give me log base 4 of 64 over 16, which is going to equal of 4. And again, what number do we raise 4 to get to 4? That little loop-de-loop. It's going to be, again, 1. So that whole logarithm equals 1. All right, now let's take something a little bit more difficult. I have log base 4, x squared minus log base 4, 8x equals 1. So this time I have an actual equal sign. I have a mathematical statement. And I'm given a log base 4. They both have 4. So let's go ahead and use what we know about that quotient property to combine this to see what we can get and see if we can solve for x. So if I have log base 4 of x squared all over 8x is equal to 1. Okay, that means that log base 4 is going to be x over 8. Because again, this I have x to the 1 and x to the 2. So that would subtract, and I would be left with x to the 1 in the numerator. And that's going to be equal to 1. So if you remember just our little loop-de-loop, 4 to the power of 1, why did it disappear? There we go. 4 to the power of 1 equals x over 8. So let's write that out. 4 to the power of 1 equals x over 8. You're going to find that writing this in exponential form is often going to be much easier for you to solve. So 4 to the power of 1 equals x over 8. Well, that just means that 4 equals x over 8. And I'm going to multiply each side by 8 to get rid of, to isolate that x, isolate my variable. That's going to give me 32. So at the end of it, x is equal to 32. So yeah, by using the quotient rule here, you actually took something that looks a little more daunting and complicated, and in just a couple lines of math, you actually got a numerical answer that holds true for this statement. So I hope you found this helpful. Hopefully the proof in some of these problems kind of helped shed a little bit more light into how honestly not complicated these things tend to be, but they just look really weird because there's like, you know, logs and scales and Richters and all that. And so when we're going forward, we're going to be going over more properties as well as a lot of the application type of problems you get into, like the Richter scale for earthquakes or the logarithm scale for decibels and sound, and financial applications as well and things like that. So don't forget to like, comment, and subscribe. We are here to help. If you have any homework questions, go ahead and drop a comment. And yeah, just let us know if these videos are helping you out. I'll catch you guys in the next one. Take it easy.